Okay, if I want to solve these simultaneous equations using the Wendy method, I can't just add all of these expressions to get rid of y, because I have to do something else first. The y cannot be subtracted from minus 3y to get rid of the y. So what I need to do first is I need to multiply equation 1, and that means the whole of equation 1, by 3. If I multiply the whole of equation 1, I will get 3y up here, and that I can take away minus 3y from to get 0. So the first thing you have to do is see how can I manipulate this equation so I can put it in the form that I want. Let's multiply the top equation by 3, and we will then call it equation 3 down here. So we will get 3 times 3x will give us 9x. 3 times plus y will give us plus 3y. And 3 times 13 will give us 39. Now I can add these equations. I can add equation 2 and equation 3, and I will finally get rid of y, which is what I want to do. Keep everything separate again. I add my x to my 9x, giving me 10x. I add my minus 3y to my plus 3y, giving me 0, which is what I want. And then I add 11 to 39 to give me 40. 50. 39 and 11 to give me 50. So, now I know that 10x equals 50. If 10x equals 50, x must equal 50 over 10, which equals 5. So I now have a value for x. Okay, I can put that straight back into equation 1. So, substitute. X equals 5 into 1. If we do that, we know that 3 times 5 plus y equals 13. So we get that 15 plus y equals 13. Therefore, y must equal 13 minus 15 equals minus 2. So I now know that y equals minus 2. So I do my final check. I substitute x equals 5, y equals minus 2 into equation 2. And let's do it over here in a different color. Wherever I see x, I put in 5. 5 minus 3 times whatever y is. I know that y is minus 2. Should equal 11. Well, 3 times minus 2 is minus 6, but I've got a minus in the front here, so that will give me plus 6. 5 plus 6 equals 11. Does it? Yes. I've done everything right. Solved simultaneous equations where I have to actually manipulate them another way. Let's look at the Swedish way for solving this one then. Again, we have 3x plus y equaled 13. And we would get y by itself probably. So I would have that y equals 13 minus 3x. Then we have the second equation. Put it in a different color. X minus 3 times y equals 11. So whenever I see y here, I substitute y with this new expression, 13 minus 3x, to get rid of the y. X minus 3 times 13 minus 3x equals 11. This looks complicated, but it really isn't. X minus 3 times 13, 39, minus 3 times minus 3x is going to give us plus 9x equals 11. So let's move over up here where we've got a little bit more space. We then get that 10x minus 39 equals 11. Move the minus 39 over to the other side. 10x equals 50. Therefore, x equals 50 divided by 10 equals 5. We now have what x equals. We know that x equals 5. We substitute x equals 5 back into equation 1 here. And we get 3 times 5 plus y equals 13, exactly the same as we did before, so therefore y equals minus 2. So we've solved for x and we've solved for y, two different methods. One of these methods you have to start to feel comfortable with. Two equations and two unknowns is definitely something that can come up, and definitely something you need to be familiar with for gymnasiet. Okay.